Hello everyone, I welcome you all for the next session of multimedia section. In this session, we will be discussing on a new topic called media and data streams. The term multimedia is composed of two words, that is the multi, and the second word is a root word called medium. The word multi is derived from the Latin word called multus, which means a numerous. And second one, the root word called media is derived from the Latin word called medium, means middle or the center. What does medium define? The medium can be defined as a means of distribution or representation of information. Means through medium we are able to distribute the information from one place to another, or it is the form of implementing or representing the information. In the next, we talk about the different types of medias. The first one is perception media. What do you mean by perception media? Here we deal with how humans perceive information. Means how does humans receive or take the information. So information is received by humans in two things. One is auditory media and second one is visual media. What is auditory media? Auditory media is nothing but the information that is heard over human ears. It constitutes of noise, sound, and music and other things that is heard through ears. Second one is visual media. Visual media is the representation what the humans can see, the pictures, moving pictures, full motion pictures, all other things. Second one is representation media. When we call about representation media, here we deal with how information is encoded over the computer. Means how are the information represented through computer is what we deal with. When we talk about this topic, there are a lot of multimedia components. So first is the text. Text is represented as a ASCII keys. The sequence of characters are called the ASCII characters. These combination form a text. So text is represented as the ASCII format. And second one is picture. Picture is represented as CEPT or Captain format. So our Captain standard also, you can call it as standards. Then audio. Audio is a combination of data streams. These data streams need to be sampled and then quantized. PCM, that is a pulse code modulation, is used to sampling those audio signal, and then it is quantized to 8-bit or 16-bit convenient according to the system. So that is the representation used for the audio. Next is a single image. The single image is represented with the JPEG format. And finally, the combination of audio and video, these are represented over the monitors or a television. That this representation involves a cathode ray tube, CRT monitors, that is CRT monitor, then LCD and LED monitors. Next is a presentation or presentation media. What are the things that we are discussing here is, so where it is presented. So how presentation happens. It might be within constitution of the input and also with respect to output. how information is presented. When we talk about the input part of presentation, how information is presented inside the computer from the outside. Let us consider the input like the keyboards. The keyboards are used to feed the information, the text information. Cameras are used to capture the images that is taken as input and fed into the presentation of a computer. And also microphone, where the voice is observed. And the output, when you consider the output presentation, TVs are the monitors. That is the same what we have seen in the previous examples. And also paper is also considered as a presentation. So next, a loudspeaker can be considered as a presentation, because the audio things that is presented in the computer can be displayed or put forth the loudspeaker so that it can be heard by everyone. The fourth one is storage media. It deals with where information is stored. The different storage devices are used, like magnetic tapes, magnetic disks, optical storage devices, etc. So these are the different storage devices or the place where the multimedia information can be stored. Next is a transmission media. Here we deal with how information is transmitted. The information is transmitted over the coaxial cables or the cables, through satellite, even sometimes through the radio frequencies. These are the different kinds of medias. Next is information exchange. How does information exchange from one media to another media? So there are a lot of multimedia supporting devices like the pen drives. So pen drives can be used to exchange the information from one device to another device. Coaxial cables can be connected or through the network, or again the better thing is optical fibers, where high rate of data can be transmitted from one place to another. Next we look into the presentation, the next point. The next point, seventh, is presentation space and presentation value. So when we talk about presentation space, we have two things to be discussed. One is the acoustic presentation and second one is visual presentation. In acoustic presentation, we talk about stereophony. When you call about stereophony, it is very simple, saying that a microphone is used and the speakers are used to display. A person speaking the microphone can be heard over the speakers. That is called stereophony. And second one is quadrophony. When you talk about the quadrophony, it is very name itself, it says quad, four. Four speakers are placed at the four corners of the room and the music or the sound is played. The person sitting in the room feels like a surround sound is being heard. So this is the effect of a acoustic presentation. And second thing is a presentation value. When you talk about the presentation value, what kind of value is being presented? The first, text. When you talk of text, text is presented as a sequence of characters, whereas the audio is presented as pressure waves. Next is a presentation dimension. The computer representation always has two dimensions. whereas a holography and the stereography as the one more dimension, we call it as third vector dimension. Now here when we talk about the dimension, it is broadly classified into two things. Those are continuous media and the discrete media. On what parameters it is classified? It is classified based on the time dimension of the presentation space. When we talk about the discrete media, it is the things that are stationary, discrete. It is not continuous in nature. That is the text, graphics and the pictures, which are not continuous because it is stationary. It does not change over a period of time. Means on the time scale it does not vary, it is stationary. Next is a continuous. When you talk about the continuous media, it is sound. That is a video, motion, pictures, because it varies over the time scale. The content keeps on varying. And there is one more thing we need to discuss. Most of them we call it as audio plus video. We call it as video. When we say that we have a video, means it is combination of audio plus video, but synonymous says this is wrong. Audio plus video is not a video. What is that then? Audio plus video is said to be continuous media. So one should remember this. When we are talking about the audio plus video combination, we should not use the word just a video. We should say that continuous media. These are the 8 types of multimedia elements we have discussed now. Types of medias. The next topic that we are about to discuss is characterizing data streams. The statement itself, when we talk about the data streams characterized, here we are talking about the exchange of information. Means information movement. Distributed networks uses both continuous and discrete media streams. In a digital system, information is split into various packets before it is transmitted. So when we talk about the transmission, two things to be learned. One is the source. We are also call it as sender. And next is a receiver. We call it as sink. Means information is transmitted from a source or a sender to the receiver or a sink which observes the information. Data streams consist of sequence of packets. It has time component and also the lifetime. So a very good example that can be considered for the continuous media is, we are talking about the discrete media. When a good example that can be considered for the continuous media is the voice over the telephone, because it needs to be continuous in nature. Sometimes if we hear the breakage or the different breaks intervals of the time over the telephone, we get irritated with those things. So what we do, we disconnect it. So sometimes we need to have a continuous in sequence. So here the continuous example that can be considered for continuous media would be the voice over the telephone. So in accordance to these things, the different transmission mode that we can see here is, the first one is asynchronous mode. Is asynchronous transmission. What happens in asynchronous transmission? In asynchronous transmission, sender and receiver do not need to coordinate between one another at the time of data transmission. So transmission can take at any instant of time. Here a bit synchronization determines the start of the bit, and it is provided by 2-bit information at the independent clock, one at the sender and one at the receiver. The best example for this kind of transmission is the document transmission. The whole document is converted to different sequence of packets and it is transmitted. Sender starts sending the transmission at when its clock pulse triggers, and it does not wait for the receiver to be strong or enabled with the clock pulse. This kind of transmission is called asynchronous transmission. Next is the synchronous transmission. What happens in synchronous transmission? In synchronous transmission, both sender and receiver need to establish a relationship in order to exchange the information. The transmission happens at a well-defined time. So, matching both the clock pulse or both the bit synchronization, the clock triggers, the transmission happens from source to the sink. The best example that can be considered here as a telephone line example. When the person calls up, only when other person receiver reaches the sink, only then the transmission happens. It is continuous. If apart from that, if a receiver does not receiver, there is no establishment of connectivity from the source and the sink. And next mode of transmission is said to be the isochronous transmission. Isochronous transmission is said to be a combination of both, or it is different from both the things. How do we say that? It refers to the periodic signal for transmission. Time interval separates both the sender and the receiver. Means the different time intervals are there for the sender. Sender sends packets at its own time interval, whereas receiver at its own time interval. So both the time interval varies with respect to sending and the receiving. The corresponding transmission is equal to the unit of interval or multiple unit of intervals. Means it might happen at a particular intervals, or it can happen at particular or many intervals of spaces. This kinds of transmission is called isochronous. So talking about data streams, how the data data packets are transferred from one place to another, that is transmission has been discussed. So in that we have three components. One is a asynchronous mode of transmission, second one is synchronous mode of transmission, and third one is a isochronous transmission. Next we will look into the characterizing streams of data. Next we look into the characterizing continuous media data streams. So we should be cautious. We are talking about the continuous media. The characteristics of data streams that occur in a multimedia system in relation to audio and video are said to be the video transmission. Here we study about 3 points. One is a strongly and weakly periodic data streams, and second one is variation of data volumes at consecutive data packets or consecutive information units, and third one interrelationship of consecutive packets. The first one is the strongly and weakly periodic data streams. Now, to illustrate this, let us consider an example. This is a packet. We call it as why do we call all this as P1? Means almost all the time interval of all the packet is same. Over the time scale, over a period of time, let us consider the example, all the packets are equally paced. So we call this as a strongly periodic data stream. Next, Now look at this. D1 is like D1 has the packet size so much with respect to the periodic over the time scale, and D2 is so much, and D3 is this much big. But altogether, when you look into the consecutive things, again the time scale is matching with respect to T1, T2 and T3. Again, this can be considered as one period. Here looking at the same sequence with respect to the periodic data streams has been representing again here. Again, this same sequence it might be representing again here and here. That's why we call it as weekly periodic data streams. We look at the size of these packets D1 and D2. D1 is different from D2 and D2 is different from D3. But again the same set of sequence is repeated again. So we call it as periodic, but since the size is varying, we call it as weekly periodic data streams. Next is aperiodic data streams. When we talk about aperiodic data streams, all the packets over the time scale is different from one another. They never match with a subsequent sequence of the pattern, or the same pattern may appear or may not be appearing over the time scale. So these are the different diagrams of representation of strongly periodic data streams and weakly periodic data streams and aperiodic data streams. Second one, the second is the variation of data volume. Variation of data volumes between the consecutive packets. First one is strongly regular data streams. Look at this. This is the time scale. If this is the equivalent amount of data volume, it is present over the time scale, again here it is the same. If it is a T1, again it would be T1, because it has the same value of time in a complete sequence. Throughout the sequence over the time, it has the same data volume, it is not changing. So we call it as a strongly regular data stream. Next we call it as weakly regular data streams. Look at this pattern over the time scale T. D1 is different from D2, the volume size of the data packet, and D2 has a different volume size with respect to data volume D3. So it is a combination getting repeated again, D1, D2 and D3. So we call it as weakly regular data streams. Then what about irregular data streams? So D1 has this much of data volume, whereas D2 is different and D3 might be totally different, and again D4 might be different. The same sequence pattern with respect to data volume might be appearing or might not be appearing. So it is totally irregular data stream. So these are the three types of representation with respect to data volume variation. The first one is strongly regular, weakly regular data streams and irregular data streams. And the next part here we study about irregular ship or interrelationship of consecutive packets. When we talk about interrelationship between the packets, there might be regular, means interrelationship data packets might be regular, and sometimes there might be non-interrelated things. How do we look into it? First one, look at this interrelation between the packets. So this is one packet, and this is one more packet, and this is the third packet. Though there are three packets, there is a relationship between one another. Each one of the packets are connected with one another. It means there is a connectivity between those things. So we call this as interrelated data streams. Whereas the third one, there is one packet, there is a second packet, and there might be a gap. There might be one more packet, and again there might be a gap, and so on. Means there is no continuous connectivity between the packets with respect to one another. We call this as non-interrelated data streams. So under the characterization of continuous media data streams, we have discussed about the strong and weakly periodic data streams and variation of data volumes with respect to consecutive packets, and next interrelationship between the data packets. Next we will be discussing about the information units. Next is information unit. So this topic deals with the granularity. When we call our granularity, it is going in depth. So continuous media stream consists of sequence of information units within that. Based on the protocol data units, we call it as also PDUs. The units describe the logical data units, that is LDUs. Let us look at it with the help of a diagram. When we talk about a continuous media, we can consider a movie for an example. When you consider a continuous media movie, the movie constitutes or movie is made up of various clips. And what is this clip made up of? Clips are made up of a set of frames. And what does this frames made up of? Frame is a composition of lots and lots of grids. And what does that grid constitutes? Grid constitutes pixels. Now, a set of combination of pixels are combined together form a grid, and the grids constitutes of frames, and sequence of frames constitute clips, and these clips are combined together to form a one moving picture, that is a continuous motion picture, that is a movie. So what we have done, we have gone into the depth looking into the concept. We call this as granularity of motion video sequence. So here we will come to the end of this session. Here in the end of this session, I wanted to go to summarization. In the summarization, we have seen here the different types of medias. In that media, we have seen 8 types of medias. Next, we have discussed about the characterization of the data streams. Next, in the characterization of the data streams, we have talked about the asynchronous, synchronous, and isochronous transmission. And next, characterizing the continuous media data streams, where we spoke about or discussed about strongly periodic data streams, variation of the data volumes with respect to packets, then interrelationship between the data packets. And finally, we have discussed about the information unit. These are the things that I wish to share in this session. Thank you.